Hello everyone, I welcome you to all to the today's session on theory of structures. So in this theory of structures, we are going to discuss about previous year questions that were asked from this subject in 2019, right? So in 2019, so today we are going to discuss about the PYQs of 2019, right? So in 2019, there were total, just a second. So in 2019, total 7 questions from TOS were asked. Let us discuss about those 7 questions in detail. Okay. And before proceeding into the session, I request you all to please go through our scrolling here. Why? Because we are going to launch a new foundation batch from 30th of this month, June. Okay, yeah. Let us begin the session. 2019 PYQs. So here is the first question. Okay, here is the first question. A statically indeterminate structure is one which. Now let us see the correct option which suits to this given structure or question. Option A. What is option A? Cannot be analyzed at all? No. Of course, we can analyze statically indeterminate structure. Our main motto in this theory of structures is to analyze statically indeterminate structures. Therefore, first option is not correct. We can rule out first option. First option is not correct. Now, second option, can be analyzed equations of static only? No. If the structure, okay, if a structure can be analyzed by a equations of statics alone, then such a structure is called as statically determinate, right? So this option is also not correct. We can rule it out. Okay, we can rule out. No, next, can be analyzed using the equations of statics and compactability equation. Yes, of course, this is the correct option. So if you go through our TOS notes, okay, this is the, I think, second point in the note what I have given. Right. So this is the second point in the note. Direct straight away question from our class notes. Okay. Next, can be analyzed using equations of compactability only? No. Along with compactability, we require equations of statics. So the correct option for this is C. Correct option for this question is option C. So a statically indeterminate structure is the one which can be analyzed using the equations of statics and compactability equation. Clear the point? Yeah. Next question. See here, in a propped cantilever beam as shown in the figure, the value of propped reaction R will be. It means here we need to find this R. Basically, it is a propped cantilever beam. As we know that propped cantilever beam is a statically indeterminate structure to the degree 1. It means ds for propped cantilever beam is equal to 1. Okay, ds for that propped cantilever beam is equal to 1, and this additional equation we obtain by making use of compactability condition at the support B. How? See here, I'll explain this question. This is the given propped cantilever beam A, and at B the reaction R is there, and of course a moment is applied here. So moment 30 kilonewton meter is applied, and span is 5 meter, right? So now what we are going to do? First we are going to release this structure. Releasing the structure means remove this reaction. Upon removing this reaction, this structure seems like a cantilever, right? This structure seems like a cantilever. So now releasing redundant. Releasing redundant. So here the redundant is R. Okay, here the redundant is R. So upon releasing the redundant, what we will get? We will get a primary structure. Okay, releasing redundant. primary structure is obtained. Okay, primary structure is obtained. Okay, basically this is the structure we obtain AB. Okay, AB, and which is the 5 meter. Here where the moment will act 30 kilonewton meter. Okay, then what is the deflected shape in this case? So this is the deflected shape, right? This is the deflected shape, clockwise rotation. Then what is the delta over here? Let it be delta 1. So what is the formula for this delta? Which is the standard result. Okay, this is the standard result what we have studied in our strength of material. So the standard result here is ml square by 2ei. Now in our question, okay, m is given as 30 kilonewton per meter and L is given as 5 meter. Okay, this is the released structure we obtain upon redundant. Now to this we need to add the redundant also. Plus on the primary structure here we need to show the redundant. Okay, the same beam A, B and 5 meter. R. Now because of this redundant applied at the free end, this cantilever beam will deflect in upward direction, means anti-clockwise direction. So then this is the deflected shape. So this deflection let it be delta 2. Okay, let it be delta 2. What is the formula for it? Is RL cube upon 3EI. Okay. So all these were the standard results what we have studied in strength of materials. RL cube upon 3EI. Okay, RL cube upon 3EI. Now what is the compactability condition here? Compactability condition. So compactability condition is nothing but the final deflection at support B is 0. Why? Because it is a hinged joint. In other words, you can say it is a hinged support. So at hinged support, okay, at hinged support, the final deflection, it means there is no translation in horizontal and vertical direction. Therefore, we get two reactions and is asking us to find vertical reaction here. So as there is no translation, or you can say no linear displacement at the support B, and the final deflection delta should equal to 0. But in released structure, due to the load, the deflection what we have obtained is downward delta 1, and on the very same released primary structure, the deflection what we obtained due to redundant is upward delta 2. It means this delta 1 plus delta 2 should equal to 0. Okay, let us take downward as positive. So I'll consider downward as positive, that is ml square by 2ei as a positive. So as the downward is positive, therefore upward is negative. That is a quite obvious thing, right? So minus RL cube upon 3ei equals to 0. That's it, very simple. Okay, if you are solving this question in examination, so you need to do this very easily and within less time you need to do. Why? Because this formula is known to us and this formula is known to us. But here I am taking the explanation so that I am going in detail. But in examination, you are not supposed to do all these things. Simply release the structure, calculate the deflection due to the apply load, and calculate the deflection due to the redundant, and equal those two. Okay, yeah, come on, do it. Yeah, so common terms we can take here. So then we are left with m by 2 is equal to RL by 3. Basically here we want R. So R is equal to M. So M is how much? 30 given in the question. And here one more 3 is there. 3 divided by L is given how much? 5 into 2. So then it is 9 kilonewton. That's it. It's a very simple question. Okay, very simple question. So which was discussed in our class as well. So now what is the answer for this question? If you see what is the answer for this question, option A is the correct answer, right? Option A is the correct answer. Option A is the correct answer for this question. Okay, everyone. Next. So next one you see fixed beam AB. Okay, fixed beam AB of a length L. Okay, of a length L having the constants. Okay, yeah. A fixed beam AB of length L having constant flexural rigidity EI carries two loads P at its 1/3 points. Okay, at its third point C and D as shown in the figure. Numerically, maximum bending moment will occur. So this particular question, okay, this particular question can be solved by making use of principle of superposition. What is meant by principle of superposition? First we consider only this load and we ignore it and calculate the fixed end moments, and later we consider this load and we ignore it. Okay, then finally we add, means we take the algebraic summation, that might be positive or negative. Okay, it means that might be addition or subtraction, but we take algebraic summation. So algebraic summation includes if both the moments at the end are in same direction, means positive, means addition. If both the moments are in opposite direction, then subtraction, negative. Clear the point? Yeah. Right. So this beam, we can split it like this. Plus so in this way we can split this beam. Okay, in this way we can split the given beam. First let us calculate the fixed end moments here. So obviously here it is MF AB, which is in anti-clockwise direction. So basically anti-clockwise end moments are treated as negative, whereas clockwise end moments are treated as positive. Okay, that is what the sign convention we adopt. So here it is clockwise MF BA. So let this be 1 and 1. Why? Because in first case. Now here also it is MFAB anti-clockwise. So MFAB 2. Let it be 2 in second case. Now MFA BA, not A. Okay, as I said, we need to take the algebraic summation. So for this we are having the formula. It means a fixed beam subjected to eccentric point load. For that we are having a formula. So what is that formula? Let me write here. WAB square by L square for this end, and for that end what is the formula? WA square B by L square, right? Now in the given question for this A is W is the P. Okay, W is the P, and A is equal to L by 3, and B is equal to 2L by 3. Okay, for this case, and for this case, A is equal to 2L by 3 and B is equal to L by 3. Okay, clear? And W means it is a P here. Okay, it is a P here. So how to calculate it? So how to calculate MF AB1? Okay, MF AB1 is equal to minus. Why? Because minus means anti-clockwise. Minus. So W is means here P. A, that is L by 3 into 2L by 3 whole square divided by L square. Okay, divided by L square. Now please simplify it. Okay, please simplify it. So this comes out to be, okay, this comes out to be so L by 3 is there, and 2L by 3 whole square, it means 4 and 9. 9 into 3, 27, and here L square will get cancelled. So here we'll get it as 4PL upon 27. Okay, 4PL upon 27. Now if you observe, the very same moment will equal to this one MF BA2, but positive. Okay, it is positive. How much it is? PL upon 27. Is it clear? Why? The formula here is here. If you observe, why MF AB1 is equal to, why MF AB1 is equal to MF BA2 means, in this case B is L by 3 and A is 2L by 3. Now what is the formula for this? Here I will written, listen. See here I will written. W A square B upon L square. Okay, W A square B upon L square. Now for this, okay, for this the formula is W A square upon W A square B upon L square. Now here A is 2L by 3 whole square and B is L by 3. Now if you see here, yes sir. So in that case, this is B and this is A. Therefore, from the symmetry we are, and from that simple logic we can write that it as 4PL upon 27. Next. Next, MF BA1 is equal to, it is a clockwise, so positive. So positive minus, no minus, P into 2L by 3 whole square. Not 2L by 3 whole square, just a second. L by 3 and L by 3 whole square divided by L square. Now upon simplifying, it is L square by 9, so 27 will be there, and this comes out to be 2PL upon 27. Okay, this comes out to be 2PL upon 27. Now in the same way here MF BA2 comes out to be minus 2PL upon 27. Okay, minus 2PL upon 27. So here we need to add these two, because both are anti-clockwise, and here we need to add these two, both are clockwise. So upon adding, what we are going to get? So final moment at A, that is MF AB is equal to, add these two. So minus 4PL by 27 minus 2PL by 27. So then how much it is? Minus 6. Minus 6 PL upon 27. Upon simplification in the 3 table, 2 times 9 times. So how much it is? Minus 2 PL upon 27. Sorry, 9. Now here if you observe, both are also same but positive, 4PL by 27 and 2PL by 27. Upon adding, it will also give us 6PL by 27. Then MFBA is equal to the same 2PL by 9. And we know that for fixed beam, the maximum moment will occur at ends only. Okay, the maximum moment will occur at ends only. That too, what is the magnitude? 2PL by 9 at A and 2PL by 9 at B, and it means negative indicating anti-clockwise, here positive indicating clockwise. Now let us come back to our question. So see, this is the beam. Now numerically maximum bending moment will occur at, just now we have calculated, at C and D, and will be equal to 2PL by 9. Even though the value may be equal to 2 by 9 PL, okay, value may be equal to 2PL by 9, but that is occurring at A and B, not at C and D. So cancel. Between C and B will equal to P by 9. No, not maximum. Maximum is 2PL by 9. But here it is PL by 9. We can rule it out. Next. So at A and B and will be equal to 2PL by 9. Yes, correct. Right. This is correct. So option is C. Okay, option is C. Even this question was also done in our class. Okay, in our class notes. Okay, this is the solution. Next. Next one. The moment required to rotate the near end of a prismatic beam through a unit angle without translation, the far end being simply supported, is given by. Basically, this we study in the stiffness factor concept in moment distribution method, and even in slope deflection, and even in the discussion of matrix method also the very same formula is discussed. And for the very first time, this formula is being studied in strength of materials also, in the topic known as deflection and slopes. Therefore, this question is related to the standard result, standard formula, right? That is 3EI upon L. So without discussion of this formula, no one will study theory of structures and strength of materials. So standard formula 3EI upon L. When far end is fixed, it is 4EI upon L. When far end is hinged, like simply supported, it is 3EI upon L. Okay. Next. So very easy question. Next one. See, two spans continuous beam ABC is as shown in the figure below. The distribution factor at the joint B R. So distribution factor, what is the formula for the distribution factor? It is K upon sigma K. And basically what the distribution factor represents? Basically distribution factor tells us how the moment is being distributed at a rigid joint to the various members present at that joint. Here B is a rigid joint. Here how many members are there? 2. So now distribution factor in this question is going to tell us whenever there is a moment acting at that rigid joint B, means how that moment is being distributed to the member BC and BA. That this distribution factor is going to tell us. Okay, that this distribution factor is going to tell us. Now, so first we need to calculate K. So K for BC. So for B, both ends are there. One is C and another is A. It means for B, left side far end is fixed, as well as right side far end is also fixed. When far end is fixed, then relative stiffness is simply I upon L. So what is the I and L for BC? 2I divided by length is how much? 4 meter. Then how much we are going to get? I by 2, right? We are going to get it as I by 2. Next, for BA. So here also far end is fixed. Therefore, it is also I by L. Now in the question, how much I is given? 3I. So 3I divided by L. L is how much? 6. So how much it is? It is also I by 2. Now what is the summation? Sigma I by 2 plus I. Then it is simply I. Okay, I by 2 plus I is simply I. Then the distribution factor for BC is equal to I by 2 by I. That is 1 by 2, means 0.5. And the distribution factor for BA is equal to the same 1 by 2, means 0.5. That's it, as simple as that. So directly means we have solved so many number of questions on this model. Not exactly the same question, but same model. Why? Because it is one of the basic concept in moment distribution method. Even without this concept, we can't start or we can't complete moment distribution method, right? So option C, 0.5, 0.5, simple. Okay, the next one. What is the force in the member AB of the pin jointed frame as shown below? So this is the pin jointed frame. Means see, pin jointed frame means it is nothing but truss. Okay, pin jointed frame means it is nothing but truss, and is asking us to find the member AB. So this question we can answer from conceptual shortcuts, what we have discussed in our class notes. So conceptual shortcut. First conceptual shortcut discussed in the class notes of this trusses. So basically this pin jointed frame is nothing but truss. Okay, pin jointed frame is nothing but truss. So in the trusses we have discussed some conceptual shortcuts. Now the first point in that conceptual shortcut, okay, that first point in the conceptual shortcut is enough to solve this question without any calculation. So what is that first point in that conceptual shortcut we have discussed in the class? At a joint, if two non-collinear members are meeting, provided no external load acting, then force in those two members is 0. Now here you take joint A. So at this joint, two non-collinear members, AB and AD are meeting. Two non-collinear members are meeting and no load is acting. Therefore, force in the two members is 0. Now force in the AB is 0. Straight away we can answer this question. Right, straight away we can answer this question. Answer is 0. That's it. Very simple question. Without any waste of time, we can solve this question based on our conceptual shortcuts discussed in the class. Right. Next. Next is degree of static indeterminacy for the frame shown below. So he is asking us to find ds. And it is a frame. Frame means a rigid jointed structure. So here frame means rigid jointed structure. Frame means rigid jointed. So for rigid jointed structure, the formula for calculation of ds is 3c minus nr. Okay, 3c minus nr. Okay, nr. Now what is here? Number of cuts required to make stable cantilever, and nr is equal to number of releases. Okay, or in other words, okay, nr can also be interpreted as number of additional reactions added to make the stable cantilever. So very easy question. We have solved some good number of questions in the class itself based on this formula, means a calculation of ds. So if you see here, this is a frame, we need to make a cut. So how many cuts we have made here? 4. Okay, how many releases are present here? Here it is a hinge, so 1 release is present. Here it is a roller, so 2 releases. Here roller, 2 releases, and internal hinge is there, 2 members are meeting. So number of releases 1, and here 1. So total number of releases are nr is equal to 5 and 7, right? So we know the number of cuts and we know the number of releases. You simply substitute in that formula. So ds is equal to, okay, ds is equal to 3 into 4 minus 7. So it is 5. Now answer is D. As simple as that. So not exactly the same question, but we have solved some very good number of questions on this model. Okay, good number of questions. It means finding out the ds, static indeterminacy for rigid jointed structure based on this formula. So in many books and materials, you find some other formula also, but they are very lengthy and time taking. So whatever the formula here are given, that is more than enough. And of course it is easy. Easily we can find the ds. Clear? 3c minus nr. Okay, 3c minus nr. So this is what questions. Okay, these were the total 7 questions asked in the task in the year 2019. So in the next session, we will discuss about the previous year questions from structure analysis. Okay, so in the next section I will do that. So before ending this session, just I want to remind you once again on 30th. Okay, on 30th of this month, means on 30th June, we are launching a new foundation batch. So it will be very helpful and useful to you, and all the subjects and all the concepts in the concerned subject are dealt in very detailed manner. Elaborately we are going to take, okay, elaborately we are going to deal, and that too it is very advantage also to you. Okay, it is very advantageous to you. The reason you are having a plenty of time. So more time is there, it means more chances are there for you to crack the coming examination. So the as much as the more time you are having, though that much of chances you are having to crack the exam. So and that too you are now, this is the foundation batch. So we cover all the subjects in elaborate manner. So there is no hurry and worry for us. Okay, there is no hurry as well as worry. So relaxedly and by cool and calm manner, we can complete all the subjects, and definitely you will get perfect over those subjects with our training. That is for sure will ensure. Okay, everyone. Thank you, and we'll meet in the next session with structure analysis 2019 previous year questions. Okay, thank you.